So the first test that we'll look at will be the ratio test. And the ratio test tells us that for a series a sub n with non-zero terms, we have three conditions. A, if the limit as n goes to infinity of the absolute value of a sub n plus 1 over a sub n is equal to some number L, and that number is less than 1, then, I'm just abbreviating, the series a sub n is convergent absolutely, or absolutely convergent. If that limit as n goes to infinity of the absolute value of a sub n plus 1 over a sub n is equal to L, and that's greater than 1, that means the series a sub n diverges. And the third possibility is that if that limit as n goes to infinity of the absolute value of a sub n plus 1 over a sub n is equal to 1, then the test is inconclusive. So let's look at an example regarding the ratio test. So let's say we have the series from n equals 0 to infinity of 4 to the n over n factorial. So a series involving a factorial, the ratio test is going to be a good way to determine convergence. So we'll take the limit as n goes to infinity of 4 to the n plus 1 over n plus 1 factorial over 4 to the n over n factorial. And we'll simplify this limit, the limit as n goes to infinity of, we can simplify this as 4 to the n times 4 to the 1 over n plus 1 times n factorial, and then we're going to multiply by the reciprocal of the denominator, n factorial, over 4 to the n. And so this will give us, we're going to cancel out our 4 to the n over 4 to the n, and our n factorial over n factorial, and then we'll be left with the limit as n goes to infinity of 4 over n plus 1, and that's going to equal 0, which is less than 1, and so this series is absolutely convergent.